Hello class. Today we'll be talking about 8.5, trigonometric forms of complex numbers, products, and quotients. Now, you may have heard of trigonometric form or you may have heard of polar form. So they both mean the same thing. You can either have polar form or trigonometric form. They're the same thing. So then we're gonna look at a few things, which is the complex plane and vector representation. We're gonna look at trigonometric form or polar form. We're gonna convert between rectangular and trigonometric forms. We're gonna use the product of complex numbers in trigonometric form, and we're gonna do quotients of complex numbers in trigonometric form. So let's look. So the first thing we're looking at is the what? Complex plane and the vector representation. So we have the horizontal axis, which is called the real axis. So your x-axis is your real axis. And then we have the vertical axis, which is your imaginary axis. So the y-axis is your imaginary axis. It says each complex number, a plus bi, determines a unique position vector with initial point 0, 0, which is the origin, and the terminal point being AB. So if we look right here, we have 2 minus 3i. So if we were to write the actual coordinates of this, it'd be 2, negative 3. Because if you notice, it says what? The complex number is a plus bi. So to have 2 minus 3i, that means that the b was what? Negative. All right. So we know that 2, negative 3 is in what quadrant? The fourth quadrant. So that's where we draw our line to. So let's keep looking. When we talk about the sum of two complex numbers, and we say it's represented by the vector that is the resultant of the vectors corresponding to the two numbers. So let's just say if we have 4 plus I plus 1 plus 3i, we do what? We add imaginary with imaginary and real with real. So it basically would be what? 4 plus 1 in its own parentheses plus, then we'll have what? I plus 3i. And that's how we got 5 plus 4i. So just keep in mind that it's not a trick type thing. You just do what? Imaginary, imaginary, real with real. So like terms. And the 5 plus 4i would just be your what? Resultant. Your resultant vector. So it's very similar to some of the stuff we was already doing when you did what? When you added complex numbers. Now, remember in 171, you learned how to actually add, multiply, divide, do all those different things with complex numbers. So let's look at this question. So it says find the sum of 6 minus 2i and negative 4 minus 3i. It says graph both complex numbers and their resultants. So the first thing we want to do is go ahead and do what? Our sum. So we have 6 minus 2i plus negative 4 minus 3i. All right, now we're going to put our real with our real. So we have 6 plus a negative 4. Then we're going to have plus, then we're going to have negative 2i plus negative 3i. So when we do this, we'll get what? We'll get 2, then we'll get what? Minus 5i. Now, if we think about this on a plane, now I'm doing a rough draft. So when we talk about 6 minus 2i, we know we have the what? Ordered pair 6 negative 2. Then when we talk about negative 4, negative 3i, we have the ordered pair negative 4, negative 3. Then when we find our resultant, we have what? 2 minus 5i, so it'd be what? 2, negative 5. So if we look, let's say we have our first one comes out here. And let's say that this is what? Our 6, negative 2. Then we look at our other one. And it comes out this direction. Then we can say that this is our what? Negative 4, negative 3. Then our resultant comes here. This will be what? 2, negative 5. So this is just a sketch of the graph and how it would look. So let's look at some more. So the relationship among x, y, r, and theta is we have x is equal to r times cosine of theta. We have y is equal to r times the sine of theta. So r is equal to what? The square root of x squared plus y squared. Or tangent of theta is equal to y over x if x is not equal to 0. Which you kind of seen some of this before already. Usually when I would say this, if you think about what you had before, remember, what we had before was cosine of theta is equal to what? X over r. Then we had what? Sine of theta is equal to what? Y over r. We talked about this before because just like they said, what? Tangent of theta is equal to y over x, where x is not equal to 0. We talked about this in chapter 5 and chapter 6. So keep that in mind when you're doing these. So you're using previous knowledge to get these done. So don't let what you're doing, mess you up because you already know this because you already been testing on it and you already learned it. So trigonometric form or polar form of complex numbers. The trigonometric form or polar form of complex numbers, x plus yi, is r times the cosine of theta plus I sine theta. The expression cosine theta plus I sine theta is sometimes abbreviated as CIS theta or cis theta. Using this notation, r cosine theta plus I sine theta is r times cis theta. The number r is the absolute value or modulus of x plus y I, and theta is the argument of x plus yi. So take a minute and make sure you write this stuff down. Now, remember at any time you can always pause this and do what? Make sure you can write everything down. So let's look at an example of this. So it says express 2 cosine theta, cosine of 300, plus I sine 300 in rectangular form. So the first thing you want to do is look and see what you got. So let's figure out What is the cosine of 300? What quadrant is that in? It's in the what? Fourth quadrant, because 300 is fourth quadrant. Now you have a what? Reference angle. If you think about it, you have a reference angle. So let's look at what this looks like. So if we draw an axis, and we say that we have what? 300 here, and we draw here. And our reference angle is 60 degrees. So just like finding the cosine of 60 degrees. So it'll be what? 1/2. Same thing with the sine of 300 degrees. Now we know that sine is negative in this quadrant. So it'll be what? The sine of negative 60, or the sine of 60 would be what? Negative the square root of 3 over what? 2. So basically we would have what? 2 times 1/2 minus I times a negative square root of 3 over 2. So when we multiply this through, we will have what? So we'll have 1 plus so that should have been plus right here. So it's been 1 minus and then we should have what? I times the square root of 3. When you simplify it. So just keep that in mind. When you do this, make sure you watch out for these signs. Because this is plus here, it's plus up here, it should be plus right here. Then the only reason it changes is because the negative on the negative square root of 3 over 2. So, if you have any questions, make sure you ask me. So let's look. So converting from rectangular to trigonometric form. It says sketch a graph of the number x plus yi in the complex plane. Find r by using the equations. R is equal to the square root of x squared plus y squared. Find the theta by using the equation tangent theta is equal to y over x, is where x is not equal to 0, choosing the quadrant indicated in step 1. So if you follow those rules, you should be able to get through the problem pretty simple or pretty easily. So let's look at a problem. So it says write the negative square root of 3 plus I in trigonometric form. Use radian measures. So now we have to look at something. So if we were looking at our, let's say our point would be what? Negative square root of 3 and what? 1. Because it's the number that's in front of I is going to be 1. So if we looked at a sketch of this, and I'll write it over here to the side, it'd be going like this. And let's say if we had a right triangle, we'll say it'd be 1 going up, then we'll have what? Negative square root of 3. Now, what else will we have? So if we was looking for r, it'll be r is equal to the square root of negative square root of 3 squared plus what? 1 squared. So r was just equal to the square root of 3 plus 1. So r is just equal to the square root of 4. So r is equal to 2. And you'll have 2 here. Which you probably knew that from what? Your perfect triangles. The 30, 60, 90 triangles, where you have similar things. So now let's look at something. Now let's get theta. So to find theta, we have what? The tangent of theta is equal to 1 over negative square root of 3, which that is just what? The square root of 3 over 3, which is negative. So theta is equal to the tan inverse of negative square root of 3 over 3. So now we have to look at the quadrant that we're in. All right. So since we're in the second quadrant, this is going to be what? A number that's higher than what? 90. But less than what? 180. So when we get this, put it in radian form, you should get 5 pi over 6. Remember, it's a 30, 60, 90 triangle. Your reference angle here will be what? Will be 30, right? Your reference angle is 30. That's why it's 5 pi over 6. So when we go and write this in our form, we will get 2 times the cosine of 5 pi over 6. Then we'll get what? Plus the sine, well, I times the sine of 5 pi over 6. And then we're going to do what? Close that off. Or you could just do what? You could have did the abbreviated form. You could have said it's 2 times cis of 5 pi over 4. Or 5 pi over 6, sorry. So it's either or. So don't let it fool you. You can write it shorthand, as you see. So just make sure you remember your basic knowledge that we went over during the class. About the 30, 60, 90 triangle, about the reference angles, about the different sides, how to find the inverse of a side if you need to find it. So just make sure you're trying to find the angle, you got to take what? The tangent inverse. So when you take tangent inverse, it gives you what? Now, in your calculator, if you don't have it in the right thing, it's going to give you degrees. So if it gives you the degree, you can convert the degree into radians, but you got to remember that your degree, what quadrant that you are in when you plotted this thing. You know we are in the second quadrant because what? X's are negative, Y's are positive. So keep that in mind. So let's go to our next example. So let's look at this. Negative 3i. So therefore, if it's negative 3i, that means we have 0, negative 3. So if we were to draw X and Y, all right. So when we look at it, we know that we will have what? So let's say it's going to come to this part. So if I were to draw So we know we would start here because that'll be what? Our initial point. Then we would come here. That would be my 0, -3. It should be on the x-axis. I mean the y-axis. Should be on the y-axis. So when we solve this out, this is going to be what? R is equal to the square root of 0 squared plus what? -3 squared. So R is equal to what? The square root of 9, which is equal to what? 3. Now, keep in mind, we cannot find the tangent of theta, which is y over x. Because why? X is equal to 0. But we do know what? The value of theta. Because what? If you remember, this is 0, this is 90, this is 180 degrees, and this is 270. And then this is to be 360. So if we were to write it, it'd be what? It'd be -3i is equal to 3 times the cosine of 270 degrees plus I times the sine of 270 degrees. Or we have what? 3 cis 270 degrees. Remember, you can do shorthand, which is your shorthand, or you can write it the longer way, which is this. So it's basically kind of up to you on how you want to write it. Now, you remember your questions are very specific on how it wants it. So you got to make sure that you're doing it correctly. All right. Now it says write each complex number in its alternate form using a calculator approximation. So if you use a calculator approximation, we're just doing what? Cosine 125. So when we do that, we will get 6 and then we got times. We got negative 0.5735764 Then we got plus, and I got I times 0.81915200,443. Now, that's when you put the cosine of 125 and the sine of 125 in the calculator. Now, we're going to multiply this by 6. So we'll get roughly, we'll get negative 3.4416, or 15, excuse me. Then we're going to have plus 4.9149i. So as like you see, it says what? Approximation. So you have to make the necessary approximation. And when you do your problems, it's going to tell you exactly how many decimal places you want to go. So let's look at another example. Let's look at 5 minus 4i. So the first thing we need to do is find what? Our r. So r is equal to the square root of 5 squared plus negative 4 squared. So r is just equal to what? 25 plus what? 16. So r is equal to the square root of what? 41. So now, let's find theta. So we got the tangent of theta is equal to what? Negative 4 over 5. So we need to do the tan inverse. Of negative 4 over 5. So when we do that, we have to do what? Make sure your calculator is in degree mode so you can get the correct answer. So let's put it in the calculator. So if we do second tangent theta, which is going to give us tan inverse, and we did negative 4 over 5. Now, what it's going to give you, it's going to give you negative 38.66. Now, it's going to give you negative 38.66, but you know that we're looking for positive thetas. So if we're looking for a positive theta, all we got to do is do what? Look at the quadrant, which it should be in quadrant what? 4. So if it's in quadrant 4, we know that all we got to do is do what? Subtract that or add it to 360. And then it gives us what we need. So our theta in the positive would be what? 321 point what? 34 degrees. Because when you put it up here, you get what? Negative 38 point, what is it, 66 degrees. But we want the positive theta. So we get this one, which is in the fourth quadrant. So when we write it, we have r, so we have the square root of 41 times cis theta, which is what? Now we just put it in parentheses, 321.34 degrees. And that is from your 5 minus 4i. So when you get used to doing this, it'll come easy to you. So just try to make sure you try these problems and make sure you do them multiple times. All right. So now let's look at product theorem. It says if R1 times, now I want to say do it like this. So if R1 times the cosine of theta 1 plus I sine theta 1 and R2 times cosine theta 2 plus I sine theta 2 are two complex numbers, then you take the two of those and you multiply them together. You multiply the two r's, R1 times R2. Then you have the cosine of theta 1 plus the cosine of theta 2 plus I sine theta 1 plus theta 2. Or you can look at the concise form, or the compact form, which is R1 cis theta 1 times R2 cis theta 2, which is equal to R1 cis theta R2 cis, R1 times R2 cis theta 1 plus theta 2. So remember, it's the same concept, but we're going to, it's a more concise form. So you're adding the two what? Thetas together. So take a minute and write this. Then we will go through an actual problem to show you how this actually works out. All right, example. It says find the product of 3 times the cosine of 45 plus I sine 45, and the cosine and 2 times the cosine of 135 plus I sine 135. Write the resultant in rectangular form. All right? So we multiply. So if you remember, we need to first do what? We want to multiply our r's. So it's 3 times 2, right? Now it's time the cosine of 45 plus 135, both of them degrees. Then it's plus I sine of 45 plus 135, and both of these are degrees. Now we're going to have what? 6 times, and this is the cosine of what? 180 degrees plus I sine 180 degrees. Now, we know that what? We're going to have 6, and this is going to be times what? -1. Now, what happened to the I sine of 180? Remember that when you have the sine of 180, it equals what? 0. So that cancels all that out. So this would just be -6. And that's all you got to do for that. Just got to remember, and this is in rectangular form. So if we were to look at what it is, it'd be what? -6, 0. So if you didn't understand anything that I did, just make sure you go back through it and you ask questions about it. So let's look at quotients theorem. So same concept, but you're doing what? R1 times cosine theta 1 plus I sine theta 1 over R2 times cosine theta 2 plus I sine theta 2. And instead of adding the two thetas, you're going to do what? Subtract them. And then instead of multiplying the two the two r's, you do what? Divide them. So make sure you get this written down, but you know, you can always pause it and then write the stuff down. So let's look at the example. So we start off with 10 cis of -60. And then we got over 5 cis 150. Now it says write the resultant. So when we write this out a little bit, we know that this was what? Equal to 10 over 5 cis. Then we can go ahead and say we had -60 minus 150 degrees, both of these degrees, which this is what? 2 cis, and this would be what? -210 degrees, which is equal to what? 2 times the cosine of -210 degrees plus I sine of -210 degrees. Then, when we look at what this equals, this will be 2 times what? Negative the square root of 3 over 2 plus I times what? 1/2. So the cosine of -210, it'd be negative square root of 3 over 2. And you know it's negative because it's in what? The third quadrant. Then we have same case for the other one, but so same case here. So we know that 210 is in the second quadrant, but we got negative 210. So if we got negative 210, it should be what? In the second quadrant because it's going the other direction. Then your your sign should be positive. So now, when we multiply, we will get what? This negative square root of 3. Then we're going to get plus I. And that'll be your answer. So make sure you copy that down and make sure you understand what you're doing. Now, if you got confused about where everything is, just move around. So we're going this direction. You know that's 90. 180. Then we go 30 more. Right? So just keep that in mind. That's 210 degrees. Or negative 210 degrees. Let's go that direction. And then this one will be 60. So just keep that in mind. And you want to make sure you understand what you're doing. So if you have questions about this, make sure you send me an email or you hit me up through Microsoft Teams, or if you need any extra help, you go to OneNote and ask any questions that you need, and I'll show you through there.